Chris from the Cam Factory, and today we're going to be creating a manufacturing plan, or a machining strategy, for this part. We'll discuss all the variables we need to take into consideration when creating our plan. If you're watching this video on YouTube and you'd like to follow along, there's a link to the 3D model and the drawing in the description below. The first thing we'll want to do is analyze the CAD. The drawing will tell us the design intent. We'll see the material type, the datums, the tolerances, etc. The 3D model will help us better understand what we're looking at. So let's take a look at the 2D drawing. A good starting point is the notes section. This drawing includes 5 notes. Only 3 of them concern the machining process: material type, edge break, and dimensions applying after finishing. I'm not too concerned with the buildup of Type 2 ano, but I will make a mental note as we scan the rest of the drawing. The next stop is the tolerance block. This will show us the default tolerances that will be applied to any dimension that doesn't have a specific callout. In this case, the default is plus or minus 5 thou for 3 decimal places, which is pretty standard. Now that we have some of that basic information out of the way, let's take a look at the geometry. What I'm looking for here is anything that will require special attention while programming, and I'll highlight them. On this part, there are only a few things that stand out. Up here we have the 3 inches plus or minus 2 thousandths. Down here we have 1 1/4 inches plus 2 thousandths minus 0. And over here there's a section view. And detail A shows us that are 2 dimensions, but the default tolerance of plus or minus 5 thousandths will apply to them. Now this drawing is super simple because it's not a real part. I designed it for this video. In most cases, there'll be a lot more information, specifically datums. Now that we have a general understanding of the customer requirements, let's take a look at the 3D model. First, I'll map the drawing features to the part. In some cases, I'll change the color of the faces to help me visualize which features I'll want to pay close attention to while programming. This drawing doesn't have any datums called out, but if it did, I may want to apply different appearances to those datums as well. This is especially helpful when you're working with a part that has several datums, dowel holes, and a variety of thread callouts. But now that we have this information, now I can start thinking about how I'm going to approach this part, and this typically starts with 2 questions. The first is, can I machine the entire part in one operation? And if not, what are my fixturing options? Considering this part has features on all sides, it's not the best candidate for a one-operation strategy. So that leaves us with question number 2. What are my work holding options? I have a nice flat surface on the bottom of the part with a profile that would be conducive to a simple soft jaw design. I have 4 holes on the bottom, which look like clearance holes for 1/2-inch bolts. I have 2 holes on the top of the part that look like clearance holes for 3/8-inch bolts. I also have a precision machined hole down the center that may be of use. As we consider our fixturing options, it's important to anticipate challenges and come up with solutions in parallel. For instance, if I orient the part in this way in Op2, what will be happening to the unsupported feature as I machine the excess material from the top? How will this specific material type react? What are the tolerances on the feature? Do I need to consider support material when designing my fixture? It's also important to consider how the orientation will affect the relative locations between the features and the datums. It's best if you can machine the datums and the features in the same operation, but that's not always possible. Try to keep in mind how your compromises will affect the outcome, and be proactive in mitigating those issues with your programming and your fixturing. One last thing that comes to mind is to take note of any features that will require any tooling purchases. It's best to get this out of the way as soon as possible. So going back to this part, my initial thought is to place this part in a soft jaw, but there are more factors that we need to consider. First, let's consider the order details. Quantity. A short run will have different criteria than a production run, so we'll keep that in mind. Turnaround time. The turnaround time will dictate how we manage our time. It will also dictate how we manage risk. There are 2 ways, essentially, to make a part quickly. The first is what I call the quick and dirty. You design a fixture quickly that you think will work, You program fast, you cut fast, and you hope that if anything goes wrong, you still have enough time in your timeline to correct those issues. Another philosophy is the slow is smooth and smooth is fast. With this, you take a little bit more time in your planning and you try to get it right the first time, which is never a bad idea. Now, the last thing that we'll want to consider in the order details is the sale price. Now, depending on your organization or your position within that organization, you may or may not have that information available to you. But if you do, use it to your advantage. You don't want to spend a bunch of time and money on this project if it wasn't in the budget. Next, let's look at our resources, the first being the machine. Understanding what machine you're going to program for will give you an idea of what hardware is available for you to use. And then there are people resources. Will I be running this job? Will somebody else be running this job? Do either of us have additional duties we're responsible for while this job is running? Understanding the personnel constraints will give us a better idea of what an appropriate cycle time is for this job. If the part has a short cycle time and we don't have someone available to stand at the machine all day, it may be a good idea to run several parts at once. If one operation is really long and the other is really short, it may be a good idea to see if we can divide those toolpaths more evenly between operations or balance the load through quantity of parts per machine. All of this information must be considered when developing our manufacturing plan, because this information will determine if our plan aligns with our company's goals. In this case, I'll demonstrate how I would program this part if it was a small prototype run. We'll say the order quantity is 10, the turnaround time is 5 days, and the machines available to us are a UMC 500 and a VF2. Due to the low quantity of this order, I'm going to choose the UMC for both operations. This will minimize downtime for setup and breakdown. I'll keep the tooling the same between the two operations, and we'll only have to swap the hard jaws for the soft jaws. This will prevent any scheduling issues that may arise if the availability of the VF2 changes. In that case, you end up with parts sitting on a cart idle when they could have been finished in an hour or two. But let's get back to the part. I'll orient the part with this face side up in Op1 so I can flip it around and sink it into a soft jaw for Op2. Now that we have a manufacturing plan in place, we can bring this part into an assembly with our vices and begin designing the soft jaws. I created the assembly off camera, so I'll give you a walkthrough right now of what we're looking at. For Op1, I'm going to put it in a 5th axis vise. We already have the stock body in this assembly. And for the final operation, I'm going to swap out those hard jaws for some soft jaws, and I'll draw those soft jaws right now. So what I'm going to do is enter into the soft jaw component and draw a sketch on the top plane. First, I'll grab some geometry from the part, starting with the 4 outer features, and then I'll grab some geometry off the walls as well. Now that I have that, I can hide my part, and I'll draw some lines from the tangent point of this arc connecting the 2 lines that I just made. And finish the sketch. Now I can do an extrude cut. And I'm using a parameter here, so I can change it if I need to later. And just like that, we have the basic soft jaw. I'm going to add some fillets to any sharp edges, just to be sure I don't gouge my part. And I'll make that radius 100 thou. And that should be good. Now bringing my part back in here, we can see what that looks like. I think that will work well. After we've completed our soft jaw design, we can finally move into the manufacturing environment and begin applying toolpaths. But I'm going to leave it right here for this video. If you found this video helpful, hit the like button and subscribe to Practical Machinist so you don't miss another CAM video. I have more planned. If there's anything that you would like to see in a video related to CAM, leave a comment and I'll be reading through them.